Welcome to Chapter 6. This is Section 6.1, Roots and Radicals. We'll talk about square roots, we'll talk about radicals, we'll talk about how to add radicals, multiply radicals. It's radical, what can I say? So, how do we find roots of real numbers? Today we're going to learn the definition of a root and how to solve them using radicals. No variables today, just a lot of numbers, or very few variables anyway. Let's start with the idea of a square root. A square root is pretty much what you've always thought it is. When you have a number b, a square root is the solution to the equation x squared equals b. So if you have a positive number b, you got two square roots, the square root of b and the negative square root of b. Now the positive square root, radical b, is called the principal square root of b. So if I ask you the principal square root of radical 9, well, the answer is 3. Now, if something is written as x squared equals 9, that's when x is plus or minus 3. Because if you think about x squared equals 9, you can rewrite that as x squared minus 9 equals 0. So you're going to have a difference of squares where you have x plus 3 and the x minus 3 equals 0. But if I give you a question where it says radical 9, I'm only asking you to give me the positive square root. So, this is really important. The square root of 9 is 3. Not plus or minus 3. So if you have an x there, think about using the plus or minus. If there is no x, just root 9 or root 16, only want the positive square root. So there's a difference between having a variable and just having a number. The cube root of a number b is a solution to the equation x cubed equals b. So every number b, whether positive, negative, or 0, has one real cube root. And you see this written as the cube root of b, a little 3 written up here with the radical. So this is called the cube root of b. And the cube root of b cubed gives you b. So let's take a look at numbers 1 and 2. The first example is the cube root of 343. There is only one number where if you take the cube root of 343, you get that number. So you plug that into your calculator, you get the cube root of 343 is 7. If you have negative 343, the cube root of negative 343 is negative 7. You can do these on your calculator. I would not expect you to memorize all the cube roots. If you do not know how you do it on your calculator, you are basically going to use the 1/3 power for your calculator. So 343 to the 1/3 power is 7. Negative 343 to the 1/3 power is negative 7. Each of these has only one answer. Alright, this symbol is called a radical. The n refers to the index, the b refers to the radicand, and this is, of course, the radical sign. I will never test you on what these words mean, but you'll need to know what they refer to in case I mention them in class or to you individually. So, let's take a look at what all these mean in the nth root. On page 260, the book talks about what the nth root of b is. So, I'll go through these one by one, but you can read them yourself, and if you understand these, you can skip this slide and just move on. An nth root of b is a solution of the equation x to the n power equals b. If n is even and b is greater than 0, then there are two real nth roots of b. For example, let's say n is 2, and let's say b is 4. So we'll have x squared equals 4. Then the two real roots of b are 2 and negative 2. If we have x to the n equals 16, x to the 4th equals 16, then you're going to have 2 and negative 2 again are the positive roots because 2 to the 4th is 16 and negative 2 to the 4th power is also 16. If you just see it written in numerical form, the positive nth root of b is denoted this, the nth root of b. It's always going to be positive. If I put 4th root of 16, your answer is 2. The other 4th root or nth root would be negative nth root of b. So if I put negative 4th root of 16, that would be negative 2. If n is even and b is 0, then there's only one nth root, 0. So 0 to the, or x to the 2nd power equals 0 is 0. X to the 4th power equals 0. If n is even and b is negative, you will not have any real roots of b. So, for example, if x squared equals negative 1, well, no real number squared would equal negative 1. So, there is no solution. Finally, if n is odd, for example, let's say x cubed equals 8, then there is exactly one real root of n of b, whether b is positive, negative, or 0. So x cubed equals 8, x has to equal 2. 2 is the only number where you cube it equals 8. If x to cubed, x to the third power is negative 8, then x is negative 2, the only possible answer. So this is probably more complicated than it really is if you just look at the math problems, but we'll see beginning now. Example 3, we had the fourth root of 0.0081. And again, I don't expect you to do this in your head unless you can, because you have a calculator to do this. So if you were to plug this in your calculator, you would put 0.0081 to the fourth root. So the fourth root of 0.0081 is 0.3. Okay, it is not negative 0.3, it is just 0.3. Remember, when you just see a number, you're looking for the principal or positive nth root. Number 4, we have the fourth root of negative 1. Well, if you look at page 260 or the slide that you just saw 2 slides ago, if n is even and b is less than 0, there is no real nth roots of b. So this is not going to be a real number. No real number to the fourth power equals negative 1. On page 261, the book lists 3 properties of radicals. Let's start with number 1. The nth root of b all to the nth power equals b, because the nth root of b satisfies the equation x to the n equals b. Again, this looks more complicated than it is. Basically, for example, if you have the fourth root of 16 to the fourth power, they kind of cancel each other out. These are inverse functions, the nth root and n. So x to the n equals b, and if you plug in n root b for x, you're going to get b. So let's take a look at number 5. The cube root of x cubed, again, using property 1, the nth root of b to the n power is b. So the cube root of x cubed equals b. So we know the answer is x. I hope you can see that really easily. Let's go to property number 2. The nth root of b to the n is b if n is odd. Property 3. The nth root of b to the n is the absolute value of b if n is even, because the principal nth root is always non-negative for even values of n. So remember, when you see the nth root of a number, you're always going to have a positive number. So even if b is originally negative, the nth root is going to be a positive number for an even root. For an odd root, it's going to be b, because there's only one solution to an odd power of n. Number 6, the fourth root of negative 2 to the fourth power. So this is where it kind of comes in. Now, we use the third property. The nth root of b to the n is absolute value of b. So we take this out, and the absolute value of negative 2 is 2. If you want to think of it in a different way, if you take negative 2 to the fourth power, you're going to get 16. The fourth root of 16 is positive 2, not negative 2. So you're only looking for the principal root when you have an even root. So don't forget this absolute value thing. Number 7, now we have some equations, which means we're going to have possibly multiple roots. 3x squared equals 432. Let's divide both sides by 3 to get x squared is 144. So x is either plus or minus 12. Example 5. Go ahead and try this one yourself. If you simplify, you get y squared equals negative 9, and there are no real roots because no real number squared will give you negative 9. Example 9. 3x cubed plus 81 equals 0. Go ahead and simplify this if you can and see what you get. Divide by 3, you get x cubed plus 27 equals 0. So we have x cubed equals negative 27, and since we have an odd root, we will have one solution, which is negative 3. Negative 3 cubed is negative 27. Number 10, 4z squared minus 24 equals 0. So the first thing you're going to want to do is divide both sides by 4. So z squared minus 6 equals 0, or z squared equals 6. If you take the square root of both sides, remember, because you have a z, not just a number, you're going to have two solutions. So z is equal to either positive root 6 or negative root 6. So make sure you make that distinction between just a number and a variable. Number 11, we have the square root of x squared equals 7. If we use property number 3, and this is where things get a little tricky, we know that the square root of x squared equals 7. So this is where that you have to use the absolute value. So the absolute value of x equals 7. If the absolute value of x equals 7, then x can be either plus or minus 7. Now this might be a little confusing, but if you plug either one of these values in, let's say you put 7 squared. The 7 squared is 49, the square root of 49 is 7. If you plug in a negative 7, the square of negative 7 is still 49, and the square root of 49 is still positive. Remember, the square root of a number, you're always going to have the principal or positive root. So this is why property 3 exists, because even though x here can be positive or negative, the principal root is always going to be positive. Finally, we have example 12. Negative the square root of 2 minus k squared equals 2k minus 2. Now, if you remember property 3, if you have a square root with a square in the radicand, you have to take the absolute value of 2 minus k. So, negative the absolute value of 2 minus k equals 2k minus 2. Now, if you remember doing absolute value, the definition of absolute value of x is if x is 0 or positive, then the absolute value of x is merely x. But if x is negative, then you have to flip the sign. So the absolute value of x would be negative x. So for example, if x is 4, then the absolute value of 4 is 4. But if x is negative 3, then the absolute value of negative 3 is negative 3 or positive 3. With that in mind, we have to split this problem into two different k levels. So first, let's consider if k is less than 2. If k is less than 2, that means the quantity between the absolute value bars is positive, or 0. So 2 minus k is greater than 0. Let's go ahead and solve that. If 2 minus k is greater than 0, then we don't have to change the sign, like in this first scenario there. So that just leaves us with negative 2 minus k equals 2k minus 2. Let's simplify that and solve, and you get k is 0. So for values of k less than 2, the only k that works is 0. Now we have to consider what happens if the quantity in the absolute value is negative. So if k is greater than 2, then 2 minus k is less than 0, and we have to take the negative. So you get negative, which is the original negative sign, times a negative 2 minus k is equal to 2k minus 2. All I did was negate what was in the absolute value, because remember, this value is negative. The absolute value is a negative of that negative. So let's simplify that. That merely becomes 2 minus k, as the two negative signs cancel each other out. So now you solve for k, and yet k is 4/3. But there's a problem here, because 4/3 is not greater than 2. So this is actually not in the domain of k for this part of the problem. So we have to throw it out. So the only solution to example 12 is k equals 0. Alright, that's it for a very long note session on 6-1. If you are still confused, you can ask me before school. I put up this video for the benefit of those of you that did not get it in class the first time or just needed to go through it one more time.